Welcome back to Logistics Made Simple, and we're going to talk about one of the most misunderstood and oversimplified concepts in transportation logistics, and that's the concept of load factor or fill rate. Load factor or fill rate is a really simple measurement showing you the extent you have used a certain resource. Let's say you have a container. That container loads 30 tons. It has some interior dimensions, meaning you can have a certain volume loaded inside that container. If you have a load factor of, let's say, 50%, that container is half full, right? Well, maybe not necessarily. Let's say you load sheets of steel into this container. Now, the container is allowed to load 30 tons. 30 tons of steel will get you 15 centimeters on the floor of the container. The rest is air. Because, that's 30 tons. You're not allowed to load more onto the container because then it will be too heavy to handle. All the cranes, all the trucks, everything designed to handle containers rely on the container being 30 tons or less. But the container is not full by volume, even though it's full by weight. The same thing if you fill a container with toilet paper, which is a low density cargo, you will maybe only have 5 or 10 tons or something like that of the allowed 30, but the goods will, as we call it, cube out. It will fill up the entire container because it's a low density, a lot of air inside rolls of toilet paper. And there are, of course, other ways of complicating. You can have cargo that's not easily stackable. You cannot put one pallet on top of the other, meaning you can load and use the entire floor space of the container, but you're not allowed to put stuff on top of those pallets. Once you start to realize that load factor or fill rate can comprise of several different assumptions in every single case, you also realize that you really cannot compare case A, where you have 50% load factor, and case B, where you have 76% load factor. And both of them might actually be 100% if you calculate it somehow differently, or they may be 10% if you look at it in another way. Because let's say you buy a tube of toothpaste, and that toothpaste is in a small carton, a small box. There are a lot of wasted air inside that box. Not all of the box is, of course, filled with toothpaste. The tube has a complex shape fitting inside this box. That box in itself is in a larger box together with other small boxes, and that larger box might be on a pallet, and that pallet might not be entirely full to the edges. There might be some room left on the pallet, and when you put the pallet in a container, you will not exactly fill out the entire width of the container. There will be some air on the sides, there will be some air close to the door. If you multiply all these load factors, you end up with a load factor of a container full with toothpaste of maybe 30% or 40% or something like that, because the theoretical max is never attainable. Should we then stop using load factor as a term? No, of course not. But you really need to make sure that you have the correct assumptions when you use it. If you're going to compare two different cases, you need to make sure you have the same basis for comparison. And if you want to use it as a measurement of your own efficiency, you have to make sure that you have a consistent use of the concept, and be open to the fact that different types of cargo can be loaded differently in vehicles. And also, if you have 100% of a truck, it might mean that you have waited too long to let the truck leave and thereby cause troubles at the other end. And if you want to increase the load factor in a system, let's look at how a normal bus line works. Let's say you have a bus line going between 2 points like this. You want to increase the number of passengers per seat, which is a measurement for the load factor in a bus. You can do this in principally two different ways. One, you could wait until the bus is full before you leave, and thereby the bus will be full, the load factor will be 100%. Or you can actually buy a smaller bus, making sure that it gets full faster. Because you won't get any more passengers. The passengers who want to travel are a constant volume here. So the only way to do it is to adapt the vehicle or adapt the frequency of how the vehicle is traveling. Both of those solutions are suboptimal. Both of those solutions may actually hurt the system as a whole. So you really need to make sure that you know what you're measuring when you use load factor or fill rate. And it's often said, if you read newspapers or watch the news, that 40% is air when we transport stuff. Yeah, there might be a really good reason for that sometimes. And sometimes it's a really, really potential for improvement as well. When it comes to packaging, for instance, to be more concise with the product it's containing, instead of just having a large box with some fluffy material and then a USB stick in the bottom corner. We've all seen those. So load factor is a really useful tool that we definitely should use, but we should be mindful of how we use it. And I'm sure I will come back to this complex term in future videos. Please like, share, subscribe, and contact me and tell me what you want me to explain in Logistics Made Simple next.